Hi, sir.
Yeah, let me just change the settings.
Yeah, sure, sir.
Hello. Am I speaking with Shanti Dutta?
Hope my screen has become visible.
Yes, sir. Your screen is visible, sir.
Okay, good. So, okay, should I keep it there or I can take it out?
Yes, sir. You can keep it like this, sir.
Okay.
Yes, sir. Hi, everyone. Good evening. We'll start soon. Be there. Okay.
Good evening, everyone. Nikesh, please confirm. Can we start?
Yes, ma'am. Can we wait for 2 minutes, ma'am? After 2 minutes, we can start, ma'am.
Okay, sure.
Yeah, yes. Ma'am, I think we can start now.
Sure, 1 second. Very good evening, everyone. On behalf of REVA Academy for Corporate Excellence, REVA University, and Kyndryl, so glad to welcome all of you to this evening session. We are delighted to have you, Vikram. And a quick introduction about the context of this session. As you all are aware, I'm hoping that those who are part of the hackathon is aware about the context. But those who are newly joined because of the interest in the topic, let me quickly introduce that this is part of the last leg of the hackathon, which we are conducting for the past 3 months. And the whole theme of this hackathon has been Sustainable Development Goals, SDG 14, which is about conserving life underwater. And the problem statement that we have chosen for this hackathon has been that how to detect large quantity of plastic which is ending up in our oceans and rivers, and can emerging technologies like AI build sustainable solutions. With AI, can we build solutions to detect plastic, as well as help the environmentalist as well as government to help them remove this plastic from the waters, or to dispose it consciously. So this has been the context. We had excellent participation from industry and academia, and we are so delighted that now towards the end of this part of hackathon, we have 15 of teams who have been qualified now for the grand finale. One of the ask of your final evaluation would be that the solution itself, is it sustainable? Solution itself, is it sustainable? So that means plastic has created huge alarm bells everywhere, but then AI solutions, are these sustainable, or is it going to harm different way the environment? Maybe we are removing plastics, but we are emanating more carbon footprints everywhere. So are we looking at sustainable in a holistic way? So this is very critical, especially young generations who are participating in the hackathon, and generation like ours who are trying to make us, the impact has to be little lesser impactful, so that the next generation can thrive on our planet. So Vikram has been the Associate Director and Environmental Manager for environmental projects in Kyndryl. He has been with IBM and various other companies, have decades of experience on building environment, or be the whistleblower, or be the be the change maker that can we look at everything from a sustainable point of view. So Vikram brings amalgamation of sustainability in technology, and delighted to have you, Vikram, and especially the people who are in the grand finale, please look at what Vikram has to say and incorporate those solutions or those ideas in your final pitch, because there is about, though it is 10% mark has been allocated, but this is going to be sometimes a make or break for your winning. So please take this session very seriously and let us build sustainable AI solutions, irrespective of whether the solution itself is towards the sustainability. So with that, thank you so much again, Vikram. Looking forward to an engaging and enlightening session, because most of us have taken sustainability for granted and we don't know how to quantify, we don't know how to, to understand and use it on a day-to-day decisions. So over to you, Vikram, and we will have about say 45 minutes of sessions and then Q&A. So people, those who have questions, please chat away. Because some of you are muted, so if you raise your hand, we can unmute you so that you can answer. But park all your questions towards the end. Over to you, Vikram. Thank you so much.
Thank you, Dr. Shinu. Hope I'm audible, everyone. You can just give me a thumbs up if it's all good. Okay. So
you are visible. Yes.
all right. Thank you. Thank you. And thank you, REVA University, for organizing a session of this kind, and also the hackathon itself. I just had a chance to look at some of these entries, and in this grand finale, I definitely don't want to be a judge. It's something which is going to be very tough, and great job, everyone. So whoever has participated and in the finals, all the best. Whoever is interested in looking at this more, uh, keep coming with your ideas, and keep developing the sustainable part of information technology and AI. Like Dr. Shinu mentioned, my name is Vikram Verma. I work with Kyndryl, a part of the sustainability team as part of Kyndryl Corporate Affairs. And what I'll be talking to you about today is really, you are all conscious. You are all working on solving planetary problems using artificial intelligence. This session is more to just make you mindful about uh, the carbon footprint of AI, and things that you can do. So today I'm coming in front of you not as a expert in either AI or maybe even sustainability. Today I come to you as an activist. Today I come to you with an appeal, saying that look at sustainability also. It might be 10 marks in the contest, but in life there's a lot it will make an impact on our lives. So with that, I'll move to my next screen. Okay, so why are we here? Uh, we are here because we are interested in sustainability, and specifically this hackathon is about plastics floating in water bodies, rivers, and then moving on to the sea, and the effect it has on life and even health in the long term. What I just wanted to point us to is another aspect of sustainability, and that's climate change. And climate change, for those who are new, is really about the Earth becoming warmer compared to the pre-industrial age, or maybe something like 120, 125 years ago. It's become really warmer compared to then. And the world is trying to keep the temperature growth within acceptable limits in the next 60, 70 years. And a lot of action needs to happen in the next 5 to 7 years or 15 years, and that all of us need to take action. So yesterday itself, I read something that, at something like 47 degrees centigrade, chlorophyll starts to deteriorate in terms of functioning. And days like that, which used to be something like maybe 1 day in a season, 1 day in a year, happen much more frequently these days. So just imagine a day when there are many days when chlorophyll doesn't function in the world, and what would happen to it. So this is climate change is not something new. It's been happening to Earth over cycles many times. The only thing different this time is it's largely affected by human activities. And again, for the first time, it's going to be the first time where humans are going to get affected by it. So, if we need to continue our same level of life, if we want our children and great grandchildren to have the quality of life that at least we had, we need to take action and take this global warming seriously. Another piece of fact, I'm not sure whether this will be new or you're already aware of this, the information and communications technologies. So the contribution of this industry and associated industries to the greenhouse gas emissions is just about the same as aviation. So I'll let you digest that. So what's important is while we are developing solutions to solve sustainability problems using information communication technologies and in specifically artificial intelligence, machine learning, we also need to be conscious about the carbon footprint of artificial intelligence. Now, I'll just a brief background of the emissions associated with information technology. Where do they come from? So everything that we do, the software that we run, the models that we run, where the training happens, where the programs get executed, most of the times they're happening in a data center. And data centers require a huge amount of electricity. Maybe they even require fuel for generating backup electricity. They need a lot of water for cooling and keeping the servers and other equipment in a way that they are functioning and they don't shut down. There are emissions associated with the entire internet devices. So for data to travel from one corner to the other, when you write thank you email, there's the carbon footprint attached to it. So uh, everything that we do, from storing pictures to maybe even recordings of meetings like this, uh, they have a carbon footprint. The other aspect of the IT emissions are because of this devices that all of us have. So laptops, desktops, even mobile phones that we use. And very specifically in the context of what you all have been using, cameras, probably drones, some of you had about. So there are carbon emissions associated with manufacturing these devices, maybe transporting them to where they have to go, uh, maybe repairing them, and in the end, when they are not fit to be used, they have to be disposed of. So there's carbon footprint associated with everything, the entire life cycle of these devices. And then, of course, there's the supply chain, so transportation, the associated industries that go into making the IT industry work. So when we are, for all of you, it's when we are writing or when we are developing solutions, when we are uh, operating solutions, we have to be conscious that somewhere behind, it's not just what you see on the screen, somewhere behind there is some engine running, and that's consuming resources. And what kind of resources? So some figures in the center of the screen here. So the time for compute used for training models, the amount of resources need for the resources required for them to double is 3.4 months now. So and the computational resources that are going into deep learning, 3 with whatever number of zeros you could count, but that's the amount of increase that's happening. Then simple things like increasing your accuracy from like something like 96 to 98 leads to an increase of 3x in the amount of resources that get used, and that gives the term red AI. Yeah, it's the exponential increase for very little change in accuracy. The other part, uh, and I'll come to GPT over here. So the amount of time or the amount of electricity used for training a GPT-3 model just once is equivalent to uh, the amount of electricity that it takes to run one house for 120 years. And there are some figures on the right hand side about GPT-3 consuming enough fresh water to produce 370 BMW cars and so on. So which means AI is thirsty, AI is resource hungry, and what is important at that the rate at which it is consuming is increasing exponentially. So we are all here as warriors to use AI, machine learning as a powerful tool to combat climate change. But what I want all of you to be conscious of is that it's a contributor too. And what we will discuss over the next few minutes is how you all can consciously use some techniques and tools to make your AI greener. So like I said, some of these techniques you would know it better than me. And if you have questions, put it on the chat. But if it's about the techniques and how you use them and your experience with using them, anyone can answer from this group. So feel free to share on chat. Feel free to ask questions on chat. Share experiences on chat. Use the chat part of this meeting to have a conversation going about it. So quickly, two concepts. I'm at the bottom of the screen now. One is green AI, which means the efficiency of using the resources so that the environmental impact, or what we call the carbon footprint of artificial intelligence, is lower. It is more environment friendly. The second part of it is expanding this horizon, is not just green, but including the environment, social, and economic aspects. So AI has an impact on everyone's lives, everyone's livelihood, and the way people live in society. So we should be looking at that impact, and that's in a way uh, I'll define it as sustainable AI in general. So green AI is a subset of sustainable AI. Moving on, a very busy chart, but I'll kind of break it up without reading everything. Similar to the slide earlier, it's about two parts to it. One is efficiency in AI, and the next part is responsible AI. When we talk about efficiency, it's about making it compute efficient. You use optimum and less compute resources. Don't assume that it's unlimited. And the second part of this is be data efficient. The amount of data used for training, the amount of and the way you use the data and how you structure the data. So you should be data efficient, and we'll just talk about this in some time again. What I wanted to spend time on this slide is on the right hand side. So the ethical and social aspects of AI, using data in a secure manner. Uh, you should ensure that bias is not there by using a diverse and representative data. We've all heard of stories of because you've just fed it one kind of data, it favors a particular community. Then a thing, and then if AI is used for decision making, it should be explainable. The models that you use and the so if somebody has a question why the decision was taken, there should be a way to get back to it. And last, not the least, and probably something that you don't have an option about is there are regulations coming up all the time, and we need to be aware of it and follow the applicable regulations uh, in order to be in business. Otherwise, of course, there'll be lawsuits and things like that. The last one, a bit subtle, but this is something if you're starting out, make it a habit to think about is uh, the environment and economic impact. So, for example, just in the use case that you have worked on in the hackathon, if cameras are to be used for detecting plastic in rivers, and the cameras are procured from a company that uses child labor, it's not good. If it's procured from a company that maybe puts hazardous waste back into rivers, that's not good. So where you are sourcing components from and what is the environmental attitude of that company is important. Uh, we might be, so I guess you get the point. When we are sourcing materials, we have to ensure that we are responsible for the entire chain. We find out where it's coming from and where it will get disposed. Of course, efficient use of raw materials by yourself as well as the people you work with, responsible end of life handling of the equipment. And then always when you're working on something, think about the social and economic implications. There are poor people going to get affected? Is a particular community going to get affected because of what you do? And how can you identify those risks and include those in the work that you do? So moving forward and getting into a bit deeper into the green AI and efficient AI, I'll be going through some ways in which to kind of dissect this. But like I said, you are all probably better than me at understanding this. My only request is go through this at your own pace later on, get into these points and try to include it in the work that you do as you keep going on. So I have some good practices in the next 3 or 4 slides. The first is with the dimension of hardware and infrastructure. So there would be specialized hardware available, and depending on the applicability, try to use the specialized hardware because there will be speed advantages and energy advantages because they have been constructed to do that job. The second is some of these GPUs provide power capping. If you use that to get the same level of performance, you could get you could do it with less power, and less power means less GHG emissions because less coal gets burned to give you the electricity. The other aspect is on-premise refers to servers and the processing and the network equipment being in your own data center. And public cloud is something like AWS or Azure or GCP or IBM Cloud. So using that. Now, studies by AWS, Azure have shown that the emissions reductions is something to the tune of 85 to 90% and the energy consumption is lesser to the tune of 90% or more. And so which means that if you run that same workload on a data center that you own, it's going to probably be much more resource intensive because the public cloud providers have a lot of money. So they put in more efficient data centers, and since they are much more densely using their infrastructure, they're able to use this infrastructure much more efficiently. And last but not the least, you are on public cloud, but there's a difference in regions. So public cloud are served from different regions across the world, and the same service can be available in multiple regions. And this comes from personal experience where we actually did a study where customer had a workload on-prem and they were moving to cloud. And what we discovered was after moving to cloud, while the study show 85 or 90% reduction in emissions, the result was the emissions, at least the calculated ones, were up 3x. Why did this happen? Because the customer's data center was at a region which had cleaner or more greener energy from hydro, and the cloud region they've chosen is something that was more dependent on coal. So, and this also gives this chart also gives the example of the emissions difference across these the regions for the same cloud service provider providing the same service. So when you are choosing cloud, based on the third bullet point, if it's using cloud, also take a look at the region from which you're taking that service. and also consider how much the data has to travel to get to your user. Moving on to the models. So use of optimized models should be more compute and energy efficient, and which means you'll need to look at which is the most optimum model that you could use. Compacting your design, so uh, working with the least number of parameters while not compromising with the accuracy. Uh, get to that sweet spot. Use transfer learning or pre-trained model to as a point for a starting point for your new model instead of doing everything from scratch. Uh, and even the choice of programming language, and this one is a pretty tricky one for me because it's maybe I don't agree with this completely, but at least in theory, that's the way it works. So some of these languages, because they work at lower levels, uh, are much more efficient in terms of resources compared to something like Python. But uh, your selection has to be based on what you are able to use and maintain and let your systems continue working. So, in theory, that's the choice of language also has a bearing on the efficiency of your system. And then moving on to the next stage. So you have trained and you have deployed a model and it's going to have a life. It's going to run for a lot of time. So your maximum emissions are going to be in this live phase. So retraining, when you will do the retraining and at what frequency and with what kind of data. So if you decide on and design your retraining cycles smartly, you would be using less resources. Again, you might have used a compact model, but could try continuing to fine tune this with pruning, distillation, quantization. Get to the least amount of complexity that you can reach. So that's going to be that's going to be improving your speed as well as uh, the energy efficiency. Last one, but not the least, is culture and attitude. So technical and technologies and techniques and all these tools will be there, will not be used if your culture does not support it. So as an organization, as a group, uh, when we are developing something, think about the sustainability aspect of it. And by sustainability, I mean not just the environment and efficiency in terms of the IT, but also the responsibility part of it. So everything with respect to biases uh, or uh, the cycle of procuring and disposing of equipment and so on. So evaluate all the new use cases that you bring up with a lens of sustainability. Keep it as one of the stakeholders, keep it as one of the criteria with which you will decide on how good the solution is and whether you will deploy it or not. Subject matter experts can tell you how much uh, how much accuracy is really needed. So you would know how much effort is required, how much level of resources is required if you use your subject matter experts' advice. So, uh, so do work with the subject matter experts for that use case, understand the data and ensure that you have the optimum uh, parameters to in order to work with or develop the solution. Also, many organizations have started this, and I'm sure they more and more will continue doing it because it's going to be a regulatory requirement that monitor your organization's emissions. And once the organization gets into the cycle, they will also uh, start looking at AI and everything they develop with that same mindset. So counting the greenhouse gases or the volume of greenhouse gases that you emit because of everything you do. Uh, it, it- you know, try to find ways of doing that. So finding out how you can do it. And here are some resources on the next page. So AWS and Microsoft has published something called well-architected frameworks. Also, you can find resources from Green Software Foundation. So do take out time and study all of these resources. And of course, I'm sure you'll find out more and probably you know more. Uh, but keep it in the focus and, and continue developing this field. I think that's all I had in terms of a presentation. I can pause here for your thoughts, your comments, any discussions that we need to have, or I'm not sure if there's anything on the chat.
Okay, everyone, please post your queries, or you can raise your hands and let us know. We will unmute. I know this is no, still I think I'm sure all of us are wrapping around our head on these concepts. How do we articulate and quantify this, right? Because it's a very large area to look at. But I think some of it is very, very easily doable. So look at the model accuracy. I don't think you should fret over 99% accuracy. I mean, if that is not the ask here, and in plastic detection, I think that is a good input. We also looked at what are the components that you have been using, how resource heavy the solution is. So please look at all these things, but we would love to have your questions, please. Is there any raise of hands? Okay. Are there any raise of hands? Participant from the finalist? Okay, Sarthak, yes. Can Nikesh unmute him?
Yes, ma'am. You can speak now, ma'am.
Yeah.
Hello, good evening, sir.
Great.
Sir, I have a question that while making or training the model, like for this problem statement plastic detection, we use different types of algorithm. But how should we check like which way algorithm is beneficial as a sustainable approach, or the algorithm we have choose? So how it is good or not for as a sustainable? Approach?
That's a good question. The only thing is I might not be the right person to uh, answer that one because, like I said, I'm not from the field, but if anyone else can share your ideas on that, so that would help.
I think Sarthak, because most of you are using pre-trained models, YOLO, etc. But I think more than an algorithm, so please do refer to any materials which is available. But what we have seen is the emissions are more heavy on the GPU systems that you are going to use to train the number of images. So since it is a small set of subset of the number of images that we have taken, I think more than from an algorithm perspective, I think the whole resources that pipeline is what you should look at. How many images, how much of resource heavy, how much of GPU epochs you are running. I think these are all going to create a lot of. I think there was some data Vikram was sharing, right, in terms of say the Microsoft AI, the data emissions are much more than Tesla cars. So if you are running your GPU for 4 or 5 hours, or most of the time we run it for 12 hours or so, I think we have to be really mindful that there is a price that we are paying. So look at not from an algorithm perspective is what I would say, but I am hoping that somebody else have better answers here. Please speak up. Debashish, you are there, right? Debashish, no?
So somebody raised hand. So was that to answer or there's a question?
Yeah, I think we have both Guru and Dan raising the hands. Please speak up. we can unmute. Nikesh, can you unmute them? Yes.
Yes, ma'am.
Yeah, hi. Good evening. This is Guru.
Yes.
Can you hear me?
Yes, go ahead, Guru.
Yeah, just to add point for the question and you answered, right? Maybe as you already in one of the slide you mentioned about quantization. That means when you use a floating point operation, then that quantization comes to a picture. If more of floating point operation, that will consume the more processing power, right? So we have to choose an algorithm which use a less floating point operation, and it should be a very how can I say, it should be very fast, okay, so that will give a less carbon footprint. That's the reason the more and more algos coming up just to improve the detection accuracy, right?
Yes, sir.
Okay. Thanks, Guru. That is helpful. I think I'm sure there are some written documents around different detection models thing. Can you check based on what Guru just mentioned? Yeah. Guru, you have any questions to Vikram?
No, I'm done.
Okay, okay, good. We can see Dan raised the hands. Dan, do you have a question or you have an answer? No. Okay, anyone else? Okay, that's a little, the silence is either we understood everything or we didn't understand, or there is. So it's okay. I think no questions are bad. Yeah,
Or
Sarthak,
people want to avoid data transferring over internet service. So they're not speaking.
Sarthak, please ask.
Yes, ma'am. I have another question. Like, as an esteemed company like Kyndryl, how do they manage sustainability as a large businesses, and uh, is that how, like, what is the approach for managing the different things when we have to also progress in our career and everything?
Okay, I think I can answer that one, fortunately. At Kyndryl, we are doing uh, it in kind of 3 or 4 ways, and 3 of them are internally for the company. And of course, every company, every industry has to work differently. Uh, so first part of it is setting up your environment management system, which means that infrastructure to both record your the work that you're doing and the emissions associated with it, and in a way get connected to the regulatory system. So there are multiple frameworks and reporting bodies to which we have started reporting, including the public. So Kyndryl will be releasing its what's called the ESG report in the next couple of weeks. ESG really stands for environment, social, and governance. So that report will be it's something that's in the final stages of getting released. Similarly, so there are uh, we have started reporting and our systems have started getting audited uh, for the greenhouse gas emissions reporting. And similarly, we've also started working towards ISO certifications and other credentials around sustainability. So that's one part of it. The second is Kyndryl's business itself, making it more sustainable. So there are what Kyndryl does is provide managed services, and Kyndryl has a lot of data centers, over 200 of them. So Kyndryl is working towards making these data centers greener uh, with various measures. So both in terms of the infrastructure, procuring renewable energy, and so on. So that's the second part of it, and things that require the big investments from a corporate level. The third part is culture. Like I said, culture will be an important aspect of this. So finding these employee groups, having sessions like this, awareness sessions around environment, sustainability, the contribution of IT, the contribution of what all of us do. Even, for example, data points like, if you keep your camera on in a meeting, uh, it is 96% more emissions compared to you without camera in a meeting, and things like that. And those are kind of the ground level or employee level activities that are going on. So that's what Kyndryl is doing for itself. In parallel, Kyndryl is also building up certain capabilities around consulting clients and helping clients with their sustainability journey with IT infrastructure. The second part of it, sorry, I'll pause here. So this is the first part of your question. Did you have any follow-on questions on that?
No, sir.
Okay, so and like I said, different companies in different businesses will have to behave differently. So if it is a bank, they'll have to have their own plan of how to measure it and how to report uh, so how to create their goals and report their progress against the goals. So in fact, Kyndryl is using something called SBTI, science-based targets, to set its goals for a year-on-year decrease, and it's declared that by 2040 we will be net zero. Okay, so that's what Kyndryl is doing. In the other part of how you can develop your career, it's open. In a way, like a few years back, the options were limited. It was not all that open, but today, in terms of the number of companies that are adopting various ways of recording their greenhouse gas emissions, setting targets, uh, and working towards reducing their carbon footprint. So there are opportunities for technologists, there are opportunities for consultants, there are opportunities for people who understand the greenhouse gas and related reporting protocols and softwares that help uh, companies record and manage their greenhouse gas footprint. Uh, and so on. So there are opportunities opening up and there's free learning, there's paid learning, and a lot of information that's available. You just have to choose what part of it you want to specialize and become an expert on and get deeper into it.
Okay. Thank you so much, sir.
Okay, there is a
See,
query here. He can speak. This is can you speak up? Can we directly assume that a model which do not require GPU to process, where CPU is sufficient, is more environment friendly compared to a model which require GPU to process? Or should we check for other factors? Yeah, from me it's a straight yes. So GPU actually consume, but then other factors are also to be considered. Sure, Vikram, please go ahead and answer this.
yeah, I
Hello,
think.
ma'am. Am I? Hello, sir. Am I audible?
Yes, you are.
Sir, I have a doubt that if we should check for the other factors, then what are the other factors should we check?
So again, it's mostly based on resource utilization and how much processing time you're using and so on. So again, what I would suggest is you will have to look up uh, the factors that you want to kind of fine tune and what are what could be the potential factors you should look at. Maybe it'll be different things for different people. Uh, So that's really a broad answer that I have. I'm sorry, I won't be able to give very specific pointers.
Yeah, so just to add, this is, I'm not getting Shanavas, right? So
Yes, ma'am.
because you are also building the prototype, right, and minimum viable product. So please check all the components there, because some of you are using, say, cameras to collect the data. There is a drone which is drawing the images. Then there is a GPU which is processing on the edge. Then there is a cloud deployment, right? So all these things are quite heavy on the emissions from Vikram's slides and all that. So you need to kind of see, we know it is going to be a big task to trade off between your building an excellent product versus reducing the carbon footprints. It is not easy, we know, but then at least have a slide on it, or what are the ways that you tried to reduce, or be mindful on, did you measure what could be the time taken, the resources being used to say train a new image, right? How much it will take, and to train the images totally, how much resources that you are burning, and what do you think is your estimation on carbon footprints, and what is the best way to scale without harming. I know these are all large queries, but I think this session is mainly to be aware that while we are creating a lot of noise around all these technologies, etc., along with plastic, we are also adding our own little bit of emissions to the environment and making it warmer. So you must be aware. I mean, that is the purpose. So how do you trade off? Yes.
Actually, I just want to add that in some cases, it might be that GPU is the more efficient way to go. Depends on your workload, actually. So if by using GPU, you're doing it in much lesser time, probably that's a more efficient one.
Yeah. Yes.
Sir,
Yeah.
Sir, can we take a paper from internet about that how environment about the environmental friendliness of using AI and ML models, and according to their instruction and the insights they are giving, sir, all of them cannot be possibly implemented at the same time, but most of them, sir, we tried to implement them, and sir, we would like to share that in the PPT as a slide. Sir, we have tried that. That's what I am trying to say, sir.
I would say that's excellent because, yeah, so at least in this field, all of you are far more knowledgeable than me. Maybe I brought you something that's just the starting point, but you know, you will be able to evaluate what you are going to need for your uh, particular project. I think you'll have to research and come to that what you will need. And if you've included that aspect in your presentation already, and maybe in even your prototype, nothing like it.
Thank you, sir. Thank you, sir.
Okay. Firoz has added a plus there. Firoz, you have a question, or you are just endorsing the question above? Firoz. Okay. Okay, looks like Nikesh, are there any more questions or?
No, ma'am.
Okay, so we have recorded this session. These sessions will be available for wider use as well as specific to participants. Do look at the slides more carefully. What are the ways that Vikram has told, to look at the directions. Definitely address this as part of your presentations in the last grand finale. That will help judges, because judges have to decide on this particular question of the sustainability, social impact, or environmental factor is going to come in. So please be mindful, and let's make. I mean, yeah, I think.
Ma'am,
Yes.
I've unmuted dancer. If he
Okay.
wants to add a pointer, he can, ma'am.
Okay. Done.
Oh, no, thank you. I think covered mostly, folks. while Vikram has given that view around the sustainability, the point to add is it's your decision how you want to optimize, right? Your model, your call with respect to the algorithm, and pointers with respect to what is it you're choosing as far as keeping in mind the 3 points Dr. Shinu mentioned, which is around environmental impact, on the sustainability based impact, and the ecosystem impact, right? I think that's at a very high level. I wanted to answer an earlier question, but that's taken. Guru, that was a fair answer you have given. That's all from my end, Nikesh and Dr. Shinu.
Okay. So I think at least keep a bug in your brain nagging, right? That's good to have. So let this worry you that how much carbon footprints I am emanating out of this solution, and will I clean the plastic without hurting the environment more. So we look forward to great solutions, and I am hoping that you have already registered, those who have not part of the grand finale event, but do register at our website and attend this session in person. So you would have very exciting presentations by this grand finale, the 15 finalists. They have done an amazing job. So please do visit them and encourage them, and hope that we have a great solution coming up at the end of this whole hackathon process. So thank you so much, Vikram and Dan and everyone. I think I can say Girija. So whoever is joined from Kyndryl, this has been an excellent collaboration with Kyndryl. We are so glad we could add our little bit to this bigger problem through this hackathon. Looking forward to. So more to come next whole week. We are keeping registrations open. Please do visit us in the campus, and let's work towards whatever the damage we have already done. Let's clean it up now. Thank you.
Thank you.
Everyone.
Thank you, Dr. Shinu. Again, great initiative, great objective, and all the best to all the finalists. And I guess all the finalists are winners in this case. So very happy to be here, very happy to be a part of this movement, and proud of all of you.
Thank you. Thank you, everyone. Good night. Keep learning. Bye-bye.
Bye. Thank you, Dr. Shinu.
Thank you.
Thanks, Vikram.